A haystack full of needles. Scalable detection of IoT devices in the wild. Consumer Internet of Things devices are extremely popular, providing users with rich and diverse functionalities, from voice assistants to home appliances. But these functionalities often come with significant privacy and security risks, with recent large-scale coordinated global attacks disrupting large service providers. Thus, an important first step to address this risk is to act at the ISP and try to identify and locate IoT devices in the network. While some limited solutions exist, a key question is whether device discovery can be done by inter-service providers. In particular, it is challenging for an ISP to efficiently track and trace activity from IoT devices deployed by its millions of subscribers, because traffic trends across different IoT devices are diverse. Deploying an agent inside the premise of the ISP customers is not scalable. Active measurements do not work with devices behind NATs, and deep packet inspection raise privacy concerns. In this work, we develop and evaluate a scalable methodology to detect and monitor IoT devices at subscriber lines with limited, highly sampled data in the wild. In particular, we discovered that the devices have repeated trends of communication that appear even in sample data. Detection rules can be generated using limited packet fields, and we detected devices from 77% of studied IoT manufacturers in an ISP and IXP within minutes to hours. Our methodology consists of 5 steps. We generate ground-truth data. We check the visibility of the data in the ISP. We generate the detection rules using combination of domains, IPs, and ports number. We cross-check the detection rules, and finally, we detect the devices in the wild. To generate the ground-truth traffic, we consider 56 different IoT products, and we produce idle or active traffic from 2 IoT testbeds. We have data from a large residential ISP that offers inter-services to over 50 million broadband subscriber lines. The ISP uses NetFlow to monitor the traffic flows at all border routers in its network. We then generate the detection rules by monitoring the IoT devices. The outcome is an IoT dictionary that contains mappings for individual IoT services to sets of domains, IP addresses, and ports. The amount and frequency of network traffic that an IoT device is exchanged with its backend infrastructure varies from device to device, depending on the complexity of its services. Most devices are supported by their own set of domains, and for many of them, this is just a small set containing less than 10 domains. This means that we cannot detect all the devices in the wild, but we can detect the majority of them. In fact, considering 1 hour interval, and we detect more than 1 million subscriber lines with Alexa-enabled services. And we noted some diurnal trends too. Increasing the observation period helps detecting more devices. We detect IoT activity for 20% of subscriber lines. We report the detection using a heat map, where each column corresponds to a day and each row to an IoT device with its detection level. Popular devices in the country of the ISP are more prominent than unpopular ones, or the ones that are not available in the country's market. Based on the ground-truth traffic, we use a threshold of number of packets per hour to filter out subscriber lines that actively use Alexa-enabled devices in a given hour. Based on these thresholds, we see that the number of actively used devices reaches 27,000 during the day and weekends, following the diurnal trend of human activity. In conclusion, we develop a methodology to detect IoT devices on limited sample data flow. We detect 77% of the studied IoT manufacturers in a large ISP. We were able to recognize that 20% of 50 million subscriber lines use at least one IoT device. We detected 4 million devices And most important, all the detection rules that we detect are available on our webpage. You can directly download them and use them on a different dataset. Enjoy!